Okay, this is concept number 14, which is factoring trinomials and difference of squares. Okay, so this is the last section for the end of the quarter. It's a tough section, and it's going to take you guys a lot of practice to get really good at these. Okay, it's not going to be just do the pretest and be good enough to take the test. You're really going to have to spend some time practicing these to get really good at them. Okay. When you're factoring a trinomial, okay, so we're factoring trinomials, so something that is 3 terms. Your goal is to figure out 2 binomials that when I would multiply them together, so when I would do that double distributing, it would give me this trinomial as an answer. So I'm working backwards from the multiplying that we did a few sections ago. In this case, and this one is already factored for you, and we're going to go through the steps of how to do this, but x minus 4 times x plus 2. If I were to multiply these together with doing the double distributing, so distributing the x to both terms and then going back through and distributing the negative 4 to both terms, I would get x squared minus 2x minus 8 as an answer. That means that these 2 binomials, my x minus 4 and my x plus 2, are both factors of this answer. Okay, remember when we talked about what factors are the numbers that you can, the values that you can divide out of that answer. So technically I'm factoring this x squared minus 2x minus 8 because I'm dividing and I'm splitting it up into x minus 4 and x plus 2. Now, to actually come up with these factors, okay, we have kind of 2 steps that we're going to go through. Okay, the first step is I need to figure out 2 numbers, right, 2 values that will multiply to give you the last term, which is the constant. Okay, so with x squared minus 2x minus 8, I first need to think about 2 numbers that will multiply to give me a negative 8. Those same 2 numbers that I choose that multiply to give me a negative 8 also have to add up to give you the middle term. So they have to multiply to give me a negative 8, and they also have to add to give me a negative 2. That's how you figure out these factors. So if you look here, negative 4 and positive 2 multiply to give me a negative 8. Negative 4 plus 2, when I add them, gives me the negative 2 in the middle. Okay, so that's why we had an x minus 4 from the negative 4, and we had an x plus 2 from the positive 2. So if we look at this example working from the beginning, x squared minus 5x minus 6. So I need to figure out 2 numbers. Okay? They're going to multiply to give me my constant. So they're going to multiply to give me negative 6. But when I add those 2 numbers together, they have to give me my middle term, which is a negative 5. First thing you want to do is go through and figure out your options for giving you a negative 6. Okay? Negative 2 times positive 3 would give me a negative 6. 2 times negative 3 would give me a negative 6, so just switching the signs. 6 times a negative 1 would give me a negative 6. Negative 6 times a positive 1 would give me a negative 6 as an answer. So you need to go through those options first for your multiplying. Then try adding them together. Negative 2 plus 3, when I add them, gives me a positive 1. Which is not what I needed. I needed them to add to give me a negative 5. So it cannot be negative 2 and positive 3. 2 and negative 3. 2 minus 3 is a negative 1. Still not what I needed. 6 minus 1, or 6 plus a negative 1, when I add them together, would give me a positive 5. So I'm close, but I needed it to be a negative 5. It was originally x squared minus 5x, so it needs to be a negative 5. My last option, negative 6 plus 1, is the negative 5 that I needed. So this negative 6 and positive 1 are the values that I need to use to write my answer. Okay, so now we're going to put these 2 values into your 2 binomials. Okay, the first term of your binomials is always going to be an x. When I multiply, x times x will always give me my x squared that I need. So it's always going to be an x times an x here. Then I'm going to place these values in. I have a negative 6, so x minus 6, and a positive 1, which is x plus 1. Okay? Or you can flip-flop the order. It does not matter which one comes first. So I can do x plus 1 and x minus 6. Same thing. Okay, so two numbers that multiply to give me negative 6 and added to give me negative 5. All right, let's look at another example then. So x squared plus 7x plus 10. Same rules. I need them to multiply to give me a positive 10, and when I add them, they have to give me a positive 7. These ones here, if everything in your original problem is positive, then everything in your factors is going to be positive as well. Okay, so that's just a little trick and something that you can remember to make it a little bit easier. If every sign is positive in the problem, every sign will be positive in your answer for these. So I need to figure out multiples of 10, so numbers that I can multiply to get 10 and add to get 7. Well, the only multiples of 10 are 2 and 5 or 1 and 10. 1 plus 10 will not give you 7. 2 plus 5 will give you 7. So your 5 times 2 gives you 10, 5 plus 2 gives you 7, which is exactly what I needed. So my answer is x plus 5 and x plus 2 because they were both positive values. In this example, x squared minus 8x plus 15. If the last term is positive, which we have here, I have a positive 15, both of your numbers either have to be positive or both have to be negative. In this case, so if this last one is a positive, your signs have to match this middle term. So because this is positive, my signs are going to have to match this middle term, which is negative. So both of my numbers have to be negative. Okay, they'll match that middle sign. So now I just need to figure out numbers that will multiply to give me negative or positive 15, but when I add them will give me a negative 8. Negative 3 times a negative 5 will give me my positive 15. Negative 3 plus a negative 5 will give me my negative 8. Now again, make sure, easiest way to check these is to actually go back through. Once you think you have it factored, multiply it out. Distribute this x term to both. Distribute this negative 3 term to both. Combine like terms in the middle and make sure that you get what you started with. If you multiply these out, you should get exactly what you started with. If you didn't, then you definitely factored it wrong. Okay? You have to get your original problem with these when you check them. Okay, now, second set of this notes is factoring a difference of squares. Okay, so it's just a different type of problem that we're factoring. These first ones, we were factoring all trinomials, so they had 3 terms. Next, I'm going to factor what we call difference of squares. It's called difference because there has to be subtraction with these. It's extremely important that there is subtraction in the original problem. Difference of squares, okay, because the number that is being subtracted in this problem is a perfect square. So remember, 4 is a perfect square because 2 times 2 gives you 4. 16 is a perfect square because 4 times 4 gives you 16. 25 is a perfect square because 5 times 5 gives you that. 36. 6 times 6 gives you that. 49. 7 times 7. Okay, so those are your perfect squares. If you think back to the multiplying section that we did, okay, if we had x plus 4 and an x minus 4, these were exactly the same thing, except for one was positive, one was negative. When that happened, your middle terms always canceled out. Okay, so with ones like this negative 4x plus 4x always canceled, and we were left with x squared minus 16. X squared is a perfect square, 16 is a perfect square. So this is actually your difference, because of the subtraction, of perfect squares, because 16 is a perfect square. So that's what we're going to be doing here, is working backwards from these answers to figure out what were the 2 binomials that we started with. So if I want to factor x squared minus 9, okay, because it's only a binomial, I cannot do what we were just doing in the last couple examples. right? It's only a binomial, so I can't look for the numbers that multiply to give you the -9 and then add to give you your middle term because I don't have a middle term here. So this is different than the last ones. Now, you have to make sure of two things. If it's a binomial, check to see if it's subtraction in the middle. If it's subtraction, that's a good first step. It might be difference of squares. Then it also has to be, this constant has to be a perfect square. 9 is a perfect square because 3 times itself, gives you 9. We have to figure out then what would the factors be. Okay, you can also think of it as similar to the trinomials. They have to multiply to give you -9 and technically add to give you 0, okay, because I don't have a middle term. So if you need to, you can think of it in that way as well. -3 times a +3 would give me my -9 in the middle, and they would add to give me 0, which is what I want to happen because I don't have a middle term. Okay, my middle terms cancel out. So my final answer is x plus 3, x minus 3. When it comes to difference of squares, your numbers in here will always be opposites of each other, meaning one's going to be positive, one's going to be negative. So x plus 3, x minus 3. Same value, opposite signs, so that my middle term will cancel. All right, a few more examples on the back. Another difference of perfect squares. So I have x squared minus 121. Again, x squared is a perfect square that breaks into x and x. I have subtraction in the middle, and 121 is a perfect square. 11 times 11 would give us 121. So you have to be really good at recognizing perfect squares with these. Okay? It's a binomial, so you always want to check for difference of perfect squares first. X squared minus 1. Again, 1 is a perfect square. 1 times 1 would give you that. Okay? So I have subtraction in the middle, and I have a perfect square. So x plus 1, x minus 1. 4x squared minus 25. 4 is a perfect square with this x squared, so even though we haven't always had a number with the x, it's okay if you do as long as it's a perfect square. 4 is a perfect square, 25 is a perfect square. So it breaks apart into 2x and 2x, because the 2 times 2 would give you the 4. 25 is a perfect square. 5 times 5 gives you 25. 2x plus 5, 2x minus 5. So you have to be really good at looking for perfect squares. All right, now the last 3 slides here, I'm going to add into a second video because I'm going to be out of time in this one. So I'm going to pause this one, and then I will start a second video to go over these last few examples with.